Hello everyone and welcome to the channel. So this is going to be a follow-up video to a live stream that I did recently. I want to explain a couple of things that went wrong and we kind of got sidetracked on that live stream and it was just a whole mess. So before I get into going over the problem and explaining the solution, let me give you a quick backstory of what happened. So I was covering the route selection in Cisco routers, and I was explaining how the administrative distance, the metric, and the prefix length work together to select the best forwarding path. Now to demonstrate that, especially the administrative distance part, I wanted to advertise routes using different routing protocols, and I also used different prefix lengths that actually fell under the same kind of main prefix. So let me show you that real quick. So I was trying to advertise these routes on the top here. And now on this notepad document, I've actually collected all the steps that I performed on that live stream. And we're going to go over that in more detail shortly. By the way, if you want to watch that video, it's still available on my channel and I've reviewed it myself, and that's how I've put together all these steps in this file. So anyway, back to the problem. So as you can see here, I have this main route on top here, 192.168.1.0/24, and then under that I have 2/25 routes that fall under that main /24 route. So I wanted to demonstrate that all of these routes would be installed into the routing table because they are actually separate routes because of the unique subnet and prefix length combination. And then for the administrative distance part, I wanted to advertise these routes using OSPF and EIGRP. Okay, let's go back to the topology briefly, because I'm trying to remember all the details of what exactly happened. I believe I had those static routes configured on R2 and I wanted to advertise them to R1. So I believe I did static route redistribution into OSPF first and then into EIGRP. I did not mention that clearly in my notes here, so this just says the configuration but not where it is applied. But looking at the first step here, which says redistribute static on R2, it would indicate that I did that configuration on R2. So hopefully we can make sense of this. I should have planned this a little bit better. So I'm hoping this doesn't get messy and confusing again. And actually, I'm not even sure what we have configured on this router so far. I've had this lab running for a few days now and I've been testing out different things and different routing protocols. Last time I was running some PGP AS manipulations on these routers, so we'll probably see some leftover configuration from that session. But that shouldn't bother us in this video. We don't need to focus on that. So let's just actually start by looking at the configuration on R1 and R2. And looks like I even have R3 open here, which I can close. We don't need that for this scenario. So let's just go to R1. Let's just see what we have here. Let's look at the IP routing table. Well, as you can see, we do have PGP routes here, so PGP configuration is still running. But once again, we'll just ignore that for now. Okay, let's look at the configuration on R2 as well. So we'll just look up the routing table. And once again, here as well, you can see PGP routes. Or just a single route actually, and then some OSPF routes. All right, so let's configure those routes that I had pointed to the null zero interface, because they don't actually exist on these routers. Those routes were just generated for the purposes of demonstrating route redistribution, and then, as mentioned earlier, to explain administrative distance, metric, and prefix length. So let's do that on R2 first. And we can copy it from here. And then just paste it here. Maybe I have some PGP debug going on here, so let me just do you all so we don't see those unnecessary messages. And let me just verify the same here. Okay. So now let's look at the routing table again. All right, so we have those newly configured routes here. So now we want to advertise those into OSPF so that they will be learned on R1. And they are going to be OSPF external routes. They should be type E2. So let's do that. Router OSPF 1, I believe, is the process that we're running. We can actually double check that with the show IP protocols command. Here you can see the process number. Okay, so then we'll do redistribute static like that, and then let's see if anything appears on R1. And perhaps you noticed that maybe we forgot some configuration, but I'll get back to that in a moment. Okay, so let's see the routing table on R1 again. So as you can see, these routes have been learned. And as mentioned, they are OSPF E2 routes. Okay, so this was our starting point before I included EIGRP, and then it turned into a whole mess. So let's go to that next. So let me pull up Notepad and let's see what went on in the live stream. So once again, I've been a little bit sloppy here because I have not specified where this command was issued, but based on this information here, it indicates that this command was run under the EIGRP routing process. So in step 1, I've configured static route redistribution under EIGRP, but then no routes are shown on R1. So let's follow this. So let's do that. Go back to R2 and then conf t. And actually, let me look at this first. Do I still have EIGRP configured here? Because I may have disabled it actually. It doesn't look like it's configured. Let's just look at show run quickly. Okay, it is actually not configured here, so we'll have to enable that quickly. So conf t router EIGRP 1, and then let's enable it on the network between R1 and R2. So 10.10.12.0, and we'll use the wildcard mask like that. And let's copy this, go over to R1. And apply the same configuration. All right, so the neighborhood should come up. Show IP EIGRP neighbors. Okay, so now we can run the route redistribution command. So redistribute static. Now let's see what happens here. I actually maybe should have run some debug so we could get some information, but let's not get to that just yet. So let's see here. Do we have any EIGRP routes in the routing table now? Show IP route. There's nothing. So those routes that were just redistributed into EIGRP, they are not installed into the routing table. So let's actually see what I've done next according to this document. Oh yes, so in step 2, I thought that they were not redistributed at all. So I tried to issue this command. So I wanted to define the metric for the routes that were being redistributed. And I just use a list of ones here. So perhaps you can identify a mistake here already. So I only looked at the routing table. I did not look at the EIGRP topology table. I'm thinking if I should show you the EIGRP topology table already, or if I should go ahead with this command. And actually at this point, I can reveal what I mentioned earlier about perhaps making a mistake when we redistributed those static routes into OSPF. So you understand why I wanted to run this command. So yeah, let me actually do that. So let me go into this document. This one, so redistributing routing protocols. Let me see if I can find the section right here. Okay, let's just read under introduction. No, that's not it. So let's skip introduction and go further down the document. Perhaps it's under metrics here. So let's look at this section. When you redistribute one protocol into another, remember that the metrics of each protocol play an important role in redistribution. Each protocol uses different metrics. Now here is the important part. Right here. When routes are redistributed, you must define a metric that is understandable to the receiving protocol. There are 2 methods to define metrics when redistributing routes. Now the 2 methods are, number 1, you can define the metric for that specific redistribution only, or number 2, you can use the same metric as a default for all redistribution. So you can define a default metric. So in other words, this document is saying that you need to define a metric that the routing protocol can understand. The routing protocol where you're redistributing those routes. So for example, EIGRP and OSPF use completely different metrics that are not directly comparable. So this is what I meant when I said that perhaps we've made a mistake here. Because I only issued the redistribute static command without specifying a metric. I did not include the metric in the redistribution command, and I did not define a default metric. So all in all, those routes should not have been advertised because they do not have a metric defined that the routing protocol can understand. So this is still a mystery to me, and I do have a note about that at the end of the document. So we'll just let it pass for now. If you have an answer to this, feel free to share in the comments. But without further ado, let's move ahead with the document. So let me go back to Notepad. So now this is why I have tried to issue this command, because I thought that the problem is that the metric was not defined. So let's actually just go along with this, and then let's see what happens here. Okay, so once again, I did not see the routes in the routing table, the EIGRP routes that were redistributed previously. And instead of looking at the EIGRP topology table, a little hint for you there, I just went straight back to R2 to issue the metric, or to add the metric in the route redistribution command. So let's do that. conf t. Okay, let's copy it from here and then paste like so. So you can see exactly what happens here. And actually at this point, let me go back to R2. We can look at the show IP EIGRP topology table right here. So you can see that the routes are redistributed into EIGRP. And here, let me actually show you the details for one route. Let's not keep the suspense. So you have a better understanding of what we're trying to look for here. So now those ones that I've used in the metric command, they're actually like reflected here. So you can see the bandwidth is 1 kilobits per second. That's terrible. And MTU is 1. So yeah, realistically, you do not want to use those kind of values. But I've just used it here just so I could put any values in there, just to have the command go through and hopefully advertise those routes. So now if we go back to R1 and we look at the routing table, you see that those routes are still not here. Okay, so let me go back to this document. Okay, so now here you can see that I've been smart enough to look at the EIGRP topology table. So let's run that command. And why am I doing that when I just copied the command? There we go. So now here is what threw me off. This part right here, FD is infinity. At first, I did not understand what this meant, why the FD is infinity. Like why the routes suddenly have a maximum metric and they are invalid routes when they have been advertised from R2 with an FD of 256. So that was very strange. So let's see from the notepad what I've done next. So I've tried to make the metric more realistic. I suppose at this point I did not check the metric on R2, so I did not realize that it was 256, which is actually a valid metric. So I guess my thought process here was that if I would use realistic values for the metric, it would produce a metric that is actually valid and not infinity. Okay, so let's try to do that. So let's copy this command, go back to R2, and under the EIGRP process, like so. And now we can actually run those same commands as we did before to look at the EIGRP table on R2 locally here. So show IP EIGRP topology. You can see that they are still being redistributed into EIGRP. And now you can see slightly different values here. Now these are more realistic. Okay. So now on R1, so if we do show IP route, there are still no EIGRP routes in the routing table, which at this point was baffling to me because it seems like we're doing redistribution correctly and the metric looks fine, which we can actually verify from the EIGRP topology table here. So now as you can see, the FD is still infinity. This truly confused me at the time while on live stream. All right, so let's see what I've done next. Okay, I can see that I'm trying to clear the EIGRP neighbors to see if that would reset the metric somehow. Of course, if I was smart and if I still had any brain cells left at this point, I could have just Googled and figure out the problem immediately. But we'll get back to that soon. So spoiler alert, this will not fix the problem. So I might just go ahead and skip over that part. So I'm not going to clear the EIGRP neighbors. But you can see the result here. So the FD is still going to be infinity and there are no EIGRP routes in the routing table. So let's just skip ahead. Oh yes, so here is where the fun part starts. So I decided to revert the configuration and remove static route redistribution. So let's go ahead and do that. So conf t router EIGRP 1, and I have misspelled that, a little typo there, EIGRP, and then no redistribute static. Okay, show run section router EIGRP. Let's just see. So we now only have the network statement there. So of course now the topology table here should be empty. Or yes, it'll include the locally connected network where EIGRP is enabled. So the neighborship between R1 and R2 is happening over this network. That's why it's in the EIGRP topology table. And I guess the same should be seen here. Yes, exactly. Okay, now let's just see what my thought process was here. Oh yes, at this point I was desperate and I wanted to try to only advertise one network. So I wanted to advertise one of the /25 networks right here. So let's actually run this command. And you can see that it's going to produce an error, which I'm going to explain shortly. So conf t router EIGRP1 and then the network command. So it says discontiguous mask is not supported. What does that mean? And what actually is the wildcard mask? So the wildcard mask defines what bits must match and what bits we do not care about. So the bits that must match are marked with a 0, and the bits that we do not care about are marked with a 1. So what have I done here? Let me pull out the pen tool. Okay, so what I have done here is write the wildcard mask as follows. So I'll kind of skip the first 3 octets. So as 0.0.0, but all of these are actually equal to 8 zeros. But just to like not waste time and space here, I'll just indicate it like that. Now 128, what is that in binary? Well, it's 1 0 0 0 and then 4 more zeros. So what does the error message mean? Discontiguous mask is not supported. So my problem is right here. I've put a 1 here and then continued with those zeros. That's not possible. So what actually I should have done is 0.0.0, the first 3 octets, and then another 0 followed by 1s, because we do not care about these bits, and then 4 more. And now that last octet is actually equal to 127. But of course, at this point, I did not figure it out. My brain was not functioning. and I didn't realize what was wrong here. So I just decided to ignore that command and error message and do something else. Okay, so let me remove this now and let's just move along. So let me go back here. All right, so I did not get this command to work. So then what I did is issue this command, network 192.168.1.0, and the wildcard mask 0.0.0.0.255. I don't know if I said too many zeros there, by the way. All right, so let's just go back to that. And then let's paste the command here, like so. Okay, and now let's see what happens here. Let me just quickly look at the notepad and see what was going on during the live stream. All right, so now it would appear that I went on to R1 and I guess I looked at the IP routing table as well and not just the topology, so let's go there. So now you can see that those routes have actually been replaced by EIGRP routes. So they are no longer learned via OSPF, or I should say that they are no longer installed into the routing table as OSPF routes, but they have been replaced as EIGRP routes. And then if we look at the EIGRP topology table, we can see them here with valid metric. So there is no longer the message that FD is infinity. Now, of course, here I got confused because I thought I was still advertising only this network. So I did not understand why all those three were being advertised, especially because route redistribution was removed. All right, so the plot thickens. Let's see what was next in the Word document, or the Notepad document, I should say. So let's see here. Yeah, so you can see I've been running these commands, trying to understand what we have configured on the router under the EIGRP routing process. So let's just double check that we have that same configuration now. So here we have only that one network statement. That's good. And then here, like this. Okay. So let's follow along with this Notepad document again. Yeah, so here I believe I'm still trying to figure out why all of those three routes are installed into the routing table when I guess I was only expecting that /25 network to be advertised, because that's what I originally wanted, but it didn't work because I had the wildcard mask configured incorrectly. So I issued all these commands to try to understand what was going on. Show IP EIGRP topology, show IP protocols, and it was showing that I'm routing for these networks. We can even look at that. Let's see, it's all the way down here. So routing for those networks. All right, let's see what else was on here. So you can see at this point I was getting really desperate because I decided to remove EIGRP configuration entirely. I could not figure out why those routes were still being learned via EIGRP when route redistribution had been removed and the routes were still appearing in the topology table. And not only that, but they were also being installed into the routing table and they replaced the OSPF routes. And we'll come back to that bottom part shortly. So let me just hide that. I did not really want you to see it just yet. So please ignore that and pretend you didn't see it. So of course, right now, I do not need to remove EIGRP, and I can explain why those routes are being learned and what my mistake was here. But I believe during the live stream, I just concluded that the lab was not working properly and it was the lab's fault, which quite frankly is an easy and lazy way to just cast away the problem. I still stand by what I said on the live stream, that there are situations when the lab can produce behavior that you should normally not see. This has happened to me before, so I'm not completely crazy for saying that, but in this case it was not true. Okay, so what is happening here? So why are those routes still being advertised, and why are they now installed into the routing table? Well, first of all, let's think about why they are still in the EIGRP topology table and why they are being advertised. So number one, this network command that I've issued, so routing for networks, 192.168.1.0. And by the way, you may notice a difference here. So this one shows you a /24, but this one doesn't have a mask at all. Well, because it does not have a mask, it assumes a classful mask. So that's also a /24. So now if we look at those static routes again, so IP route static. So all of these routes, they actually fall within that space. So this is why EIGRP is enabled on all those routes, and they are brought into the EIGRP topology table. So let's look at that again. Show IP EIGRP topology. Now let's actually see how they are advertised into R1. Well, they are still shown there actually. So you can see that the metric is valid. So these are eligible to be installed into the routing table. So now to the second part. Why did they replace the OSPF routes? Well, this is something that I did not remember as I was going through this whole process. EIGRP has a different administrative distance for internal and external routes. So let's actually look at the table for that from this document that lists the administrative distance values for different routing protocols right here. So the default administrative distance for EIGRP internal routes is 90, and the default administrative distance for EIGRP external routes is 170. And you can see that OSPF falls in between with a default administrative distance of 110. So now, what happened originally when the routes were redistributed into EIGRP, they were actually EIGRP external routes. And I can demonstrate that again shortly. But before that, let's just go over a couple of things here. So the administrative distance for those routes originally was 170. And the same routes were learned via OSPF, which actually had an administrative distance of 110. So that means that those OSPF routes were preferred over the external EIGRP routes. So that's why we did not see them installed into the routing table. And now that leads us to the FD is infinity part. So once again, if I had been smart enough and I had Googled that message, I would have found the answer easily. So I have a link open here from Cisco support community. And of course, our very own maestro, the amazing Peter Pollock has written an answer here. So let's read that. In EIGRP, the FD being set to infinity means that the route has been learned via EIGRP, but at the same time, it is known from another source that is more trustworthy. So the learned route cannot be used. Boom, the answer is right there. So basically the situation is like the rib failure in PGP. So you're learning the route, but it's also learned from another source that is better. Now EIGRP indicates this by setting the metric to infinity and thereby making the route invalid and ineligible to be installed into the routing table. I eventually arrived at this conclusion, but admittedly it took way longer than it should have. And actually even this video has been running on for way too long, but hopefully you can get some interesting and important information out of this. So to summarize, as Peter says in the last sentence here, that is the reason for having the FD set to infinity to explain that the EIGRP learned route is currently unusable. So if I had only looked at the topology table originally, and if I had searched for that message, because I did not remember at the time how the whole route redistribution works, and I did not remember the different administrative values for internal and external routes, but just this simple search would have fixed everything. Maybe I would still have even more brain cells left, because if you watch that live stream, I was truly confused. All right, let's go back to the topology table. So let's actually see here the details for one of the routes. So let's do like this, an extra comma there. Right here, so now you can see that this route is internal because it is learned via the network command. And actually, let's go back to R2. Now here's actually another confusing bit. So it says here that Rstatic. I guess this was actually another reason why I really could not figure this out. So I did not realize that the routes were in the EIGRP topology table because of the network command, because this would indicate that they were redistributed into the routing table, or excuse me, into the EIGRP topology table. To me, that clearly indicates that the static routes were redistributed. And actually, I don't think I'm so wrong here, because I actually have another link open. And here you can see this person has asked a question. And here's the same code that Rstatic. Once again, we're on Cisco support community. And here you can see very briefly, R stands for redistributed. So this is still a bit confusing to me. Why does it say Rstatic, which logically means redistributed static routes? But we have used the network command in this case. Okay, let's go back to the topology and then on R2. Okay, so let's look at the details here as well. Well, the same thing. So these are internal routes. So now let's go back to the original situation. So let's remove that network command. Actually, let's pull it up here. Show run, not that. Section, router EIGRP. So let's remove this. I'm not under router EIGRP. There we go. So then let's do show IP EIGRP topology. Okay, so now let's do the redistribution again. So redistribute static, and I'm just gonna do it like this without the metric. Okay. All right, so they are in the routing table again, or excuse me, in the EIGRP topology table. I keep messing those two. Now, once again, you can see the same code here, Rstatic. So this is something that's not clear to me. If you have any thoughts about this, please make your voices heard in the comments. I would like to know why those are not indicated differently. So both times, whether we've used the network command or route redistribution, they've appeared in the EIGRP topology table with the same status code. So once again, the situation was exactly the same here, and this is where we still had the network command configured. Okay, but now we're in the same situation as originally, so let's look at the topology table on R1 again. So yeah, here we can see the FD is infinity. And once again, those routes should not be in the routing table. And no, they are not. Now they are OSPF routes again. But now we know that's because of the administrative distance value. So let's look at the specifics again. So now here you can see a difference. Now this route is external. So really it does not state clearly here what the administrative distance value is and why the routes are not being installed into the routing table. So you kind of have to figure that out from those two clues. So this is what you have. Route is external and FD is infinity. So this should tell you that the administrative distance value is 170, which is higher than OSPF's default administrative distance value, which means that those OSPF routes are more preferred. And how this is indicated to EIGRP is by setting the metric to infinity. Wow, that was a long explanation, but I hope you got the full concept now. And now maybe you can understand why this was so confusing during the live stream. And also, this was an excellent demonstration of how you become blind to your own mistakes. Like, I just could not put two and two together while I was trying to figure this out on the live stream. So let me just quickly go back to the notepad again. So let me see what I had at the bottom here. So yeah, these 2 points are still unclear to me. So once again, we have not defined a metric on R2. I only configured redistribute static. But as we've discussed before, a metric should be specified because the metrics between the routing protocols are different and you cannot compare them directly. So I do not know where EIGRP got that metric because we did not define it. I don't know if newer iOS code versions have some kind of default metric by default that you don't have to define it. But as far as I know, that should not be the case. You should either put the metric with the redistribute command or define it separately as a default metric. Let's actually look what EIGRP has put in here. So if we do this, unless I already had it here, no. I guess it's put like a bunch of zeros here. Reliability 0, load 0, and this value for the bandwidth. So I'm guessing that it takes these values by default from somewhere. And actually, just out of curiosity, I'm not sure if 0 would even be a valid value. Let's actually try that. So router conf t router EIGRP 1. So redistribute static and then metric. So now let's try to use these same exact values. Because here, okay, total delay. Okay, here you can put 0. No, you can actually put 0 in this. Okay. But here, this should be for the load. And here it says load is 0. I don't know. Let's try that. Because according to this, it should be between 1 to 255. See, it's not even recognizing the command anymore, so this actually should not be valid. So let me put 1 here. Yeah, you see, now that I've changed it to a valid value, it's giving me the next parameter, which is the MTU and 1500. So technically, this should not be valid. Or more specifically, load, because it's configured as 0 here. So let's actually see this now. Yeah, now it's changed. Okay, something new there as well that I did not think of during the live stream. So yeah, EIGRP is definitely getting those values from somewhere. So I'm guessing this is a feature in newer iOS code. I don't know. All right, let's see what else was on here. Yes, the Rstatic code in the EIGRP topology table after redistribution had been removed. And we were using the network command. I should have written that here as well. So yeah, that part did not make sense to me. In my opinion, those two should have different codes. So Rstatic, to me, can only indicate route redistribution for static routes. And the network command should have something else, like via connected or something. Which actually, I guess it's like that for the other network. Yeah, see right here. Now this one makes much more sense. So we've used the network command for this, and it says via connected. Although that is attached to like a real interface. Of course, for this static routes, we were using null 0. But again, another interesting point there. So finally, as a bonus, but I'm not gonna do that in this video because we've already been running for so long. But as a bonus, you could try changing the administrative distance to a value that matches another routing protocol. This is also something that I almost did during the live stream. So once I figured out that if I want those external EIGRP routes to be installed into the routing table and replace the OSPF routes, I need to change the administrative value lower than 110, which is the default for OSPF. So at first I figured, what if I put it to 100? But that's actually the default value for EIGRP. Now, yes, we do not have any EIGRP routes in this lab scenario. And I was not going to add those either. And perhaps it would not have been a problem, but I did not want to try it at the time. Because it was already confusing enough to try to understand what was happening in the first place. But if you want to try this, go ahead and let me know the results in the comments. I might actually do this in another video myself. So, like, what would happen if I configured the administrative distance value for EIGRP and OSPF to be equal? Now, that would actually be very interesting. But once again, I do not want to do it in this video. So wow, that was a very long explanation once again. another monster video for you to watch. I'm sorry and thank you. If you've stuck around this far, I really appreciate it. Thank you for your continued support with my channel. So I guess I'll try to summarize what we've covered in this video. Well, the main takeaway from this video is that the FD is infinity really means that the same route has been learned by another route source that is more trustworthy or more preferred, and hence that route in the EIGRP topology table is not eligible to be installed into the routing table. So that's why the metric is set to infinity and the route is not valid. So that does not mean that EIGRP is configured incorrectly or that the routes are not learned via EIGRP. It simply means that the router has a better route to that network. And that route is preferred and installed into the routing table. Then the EIGRP route is marked as invalid by setting the metric to infinity. Now, then there were a couple of questions that are still unanswered. So number one, the metric for route redistribution, that was not defined, but somehow EIGRP assigned values to all those parameters, and the routes were redistributed into EIGRP. From what I know, that should not have happened, and this is also what is stated in the document that we looked at. When you perform route redistribution, there should be a metric defined. And there were two ways to do that. Either you assign the metric with the route redistribution command, or you define a default metric. And the second unclear part is the Rstatic code in the EIGRP topology table. So whether the route was redistributed or put into the EIGRP topology table via the network statement, it still showed the code Rstatic, which again makes more sense for it to mean a static route redistribution and not network statement. So I guess that summarizes what we've covered in this video. Okay, I will end things there. If you have any questions, feel free to ask in the comments. I know this got a bit convoluted and out of proportions once again, but hopefully you were able to follow along and learn something. So thank you again for watching, and I'll see you next time.